What's going on, y'all? This is Sam Thory. Welcome back to our ongoing series where we are building an AI content creator application from the ground up. We are using a Next.js template for this with LangChain and Supabase if you install it. So far, we have set up our project. We've added Git hooks using Husky and Biome and implemented essential features. We added Clerk and configured Supabase in the last video, and we set up that full authentication and database flow. We walked through the entire setup, including database schema design, protected routes, and middleware for security. In this video, we're going to build on that foundation by implementing the API layer with tRPC, ensuring type safety across our application. Before we dive into the implementation, let's make sure we have all the necessary packages installed. We'll use pnpm for this to install our dependencies as we usually do, ensuring we have the correct versions for everything. This is kind of important because if you do not have the most up-to-date tRPC version, you're not going to have full support, and there's a lot of implementations out there. So what we're going to do is take this command here and we'll paste it into our CLI here. I'll make this a little bit bigger for y'all. We have pnpm add @tRPC/client, and all of these are 11.0/rc.532. So you have @tRPC/next, same, @trp/react query, @trp/server, and then we also have @tanstack/react query. We're pulling in super JSON, and we already have Zod installed, but we'll go ahead and install it again, make sure we have the right version. So we run that, and we shouldn't have any problems with that. PM's pretty quick too, so that's all done. So this adds, like we said, all of those tRPC packages that we need. These are the core packages for client server and React integration. We're adding tanstack React query for managing our server state on the client. And we add super JSON to handle complex data serialization. We'll get to that later. And again, Zod is for input validation in our procedures that we are going to create with tRPC. So make sure everything installs correctly for you, and then we can get started. So first thing we're going to do is set up an initialization file for tRPC. So we're going to create a folder. We're going to call it, this in the root directory, call this tRPC. And this is where all of our files for tRPC are going to go. So first things first, we're going to go for a file called init.ts. And it doesn't have to be called that. There's really no naming convention there. In this one, so we start by creating our tRPC instance. This instance will be used as the base for defining routes and procedures in our app. We're going to bring in super JSON as our transformer, which helps handle complex data types like dates, maps, and sets between the client and server. We'll set up a typed context, which is crucial for having a type-safe API layer. Typed contexts let us easily integrate user sessions, metadata, or any specific request information that might be helpful for our routers. Finally, we'll export our base router and procedures to make our tRPC setup reusable. So just give me 1 second. So we'll go into our init.ts file, and we'll first run our imports here. We have init tRPC, oops, nope, not like that. There we go. And that's coming from @trp/server. We have import cache from React. We have import super JSON, as we talked about. We have import app router from /router/_app. This file has not been created yet. We'll get to that. So we can go ahead and start here, and cursor looks like it's pretty close to the correct answer here. So we have export const create tRPC context equals cache, and this is our cache behavior from React. And we're just putting in a base here, so returning a UID user. Very simple there. Next thing we're doing here is we're setting up our context, init tRPC.context. And let's see, we do need this transformer for super JSON, so that works. And we move down here, we have our create tRPC router, t.router, and base procedure, t.procedure. So that's all good. Beyond that, we also have export const create caller factory equals t.create caller factory. So are we not using this anymore? Oh, maybe not. We'll take this out for now. So it looks like we're all good without it. All right. So now we can move on. We'll just talk about that for a second. We have our router set up, our base procedure set up, our caller factory set up. So this is our initialization file here. It's kind of some boilerplate, but we do need it for sure. So now we're going to create our React query connection, where this file is all about integrating tRPC with React query, allowing us to manage server state seamlessly on the client side. We're using, again, @tanstack/React query to handle data fetching, caching, and synchronization. React query is a powerful tool for managing server state in React applications, and by using it with tRPC, we get a lot of benefits, including automatic data synchronization and caching. We again utilize Super.json for serialization, which is important for preserving data types. They're more complex than what JSON typically supports. One of the key features here is our hydrate and dehydrate functions, which allow data fetched during server-side rendering to be rehydrated on the client. This means data fetched by React query during server rendering can be transferred to the client, providing an instant load with no extra network request. So we can go ahead and start writing this, and this is going to be in that same tRPC folder. It's going to be called query client.ts. Oops, try that again. Query client.ts. In this file, we're going to import first a few things from tanstack. So we have query client, and we have default should dehydrate query. Next, we can jump down here. We have import Super.json again. And that's it for our imports. We can go ahead and export function make query client. So that's correct. And we're going to return new query client. So we'll go ahead and pull this in, but this is going to be a little bit different. Queries, stale time 30 times 1000. That's fine. We can keep that. But we also have to add some other things to our default options. So we need our dehydrate. Let's see if we can get this right here. So we have serialized data superjson.serialize should dehydrate query, where we pass in the query. Default should dehydrate query, which we're pulling in from tanstack, passing in the query, and if the status equals pending there. So we're doing an or statement, a conditional statement there. Should be good for the dehydrate, but now we need the hydrate as well. So we move on. Oops, don't need that. And the hydrate is going to be very simple. It's exactly this. Deserialize data superjson.deserialize. And we're all set for our query client connection there. So going back over, as we discussed, we're setting up our React query client. We've set up our serialization using Super.json. And with our hydrate and dehydrate, that allows us to fetch data during server-side rendering, have it rehydrated on the client. So that means that React query during server rendering can be transferred to the client, providing an instant load with no extra network request. We do set a stale time of 30 seconds for data freshness, if you look here on the query. And that basically means that React query will consider the data fresh for 30 seconds, preventing unnecessary refetches. So every 30 seconds it will refetch it. Otherwise, if there's requests that come in within that 30 seconds, it will use the old data. So that's still not a lot of time, 30 seconds. You can make that much longer, much shorter if you wanted to, depending on the app. Some apps you would need it to be much shorter. If it was like a finance app where the stock price changes every millisecond or something like that. But if it was just like a static site that you only need to change the data every couple of days, then you could set it up much longer. So a lot of configuration options there. So now we're going to move on to our server-side setup for tRPC, which this is very simple. Again, we're going to create a file here in our tRPC folder called server.tsx. Excuse me. And let's just go ahead and create it. So this is going to be server only. So we'll do import server only. Import, create hydration helpers. Oh, we got a whole bunch of them here we might be able to pull in. So that one's correct. We need cache. We have the create caller factory and create tRPC context we need from our init file. Make query client we need from our query client file. And app router from our _app file, which we have not yet created. So that's fine. We're going to export const get query client equals cache make query client. Perfect. Now we want to move on. We have a caller. So we're going to create caller factory. We pass in the app router. And then we also pass in a curried function here, create tRPC context. At the end, we're going to export. We have tRPC and hydrate client. We have this, and we're all set. So that's all we need. Obviously, we still have the red line here, but we're going to take care of that, no problem. So let's go through some of those changes we just made there. So at the top, you saw that we used the server only. Just pull that up real quick. Here we see import server only. This ensures that this file is used exclusively on the server side, avoiding accidental client-side use. Create hydration helpers right here. Function comes from tRPC React Query RSC and is particularly useful for working with React server components. This allows us to use server rendered data in our client components effectively. To avoid creating multiple query clients for the same request, we'll use React's cache function. This optimizes our server setup, ensuring a consistent context for each request. So we're all set there, and by creating a caller instance, we have a powerful tool to call tRPC procedures directly on the server, making it easier to handle server-specific logic. So this will be everything that we use on the server side, and we're also going to have a client side, which we'll now go to. So in this same tRPC folder, we're going to create a file called client.tsx. And in this file, we'll just go ahead and start creating. We'll discuss at the end what we've created. So this one is certainly going to be a use client directive file. And we're going to import a lot of stuff here. So we have query client and query client provider. There we go. Nope. There. Perfect. We are going to pull in import HTTP batch link. We're using Supabase. Not this one. We have a few more to get. Import create tRPC React. Sorry. There we go. We have JSON. Import use state. Perfect. And import make query. Oop. There we go. And import type app router from router/app, which again we have not yet gotten to, so that's fine. This part we're going to take out for now. We don't quite need that yet, but let's go ahead and start with this. We're going to export const tRPC equals perfect function. Let me space it out here. Not a function get if type of window does not equal. Perfect there. And this is correct as well. So this is basically saying if we have a process.env.vercel URL, return that. Otherwise, we're going to use localhost. And if we have a port, we'll use that. Otherwise, 3000. So we do have a couple of V variables that we need to set up. Actually, the vercel URL we should not set up locally. That should only be in production. But for the port, we don't even really need to set this up. Actually, we're using 3001 right now, so we would, but it's okay for now. So this is good. So that's looking good. Now we're going to go for another function here called tRPC provider. Let's see how it does with this. Props, children, React Node, that's great. Yes, so we're going to do, except not this exactly. So we have use state, new query client here, and then const tRPC client equals use state tRPC create client, and the links part, let's see. We have HTTP batch link URL, and this also needs transformer, Supabase. Now let's take a look at why we have an error here. We're going to return our tRPC.provider, And we are passing in our tRPC client, our query client provider. We're passing in the query client, and then that goes down to our children. So we have a couple of errors that I'm going to take a look at right now. I don't see any issue with them currently. We're defining tRPC up here where we have our create tRPC React with the app router. That looks correct. Our get URL should be fine. Our query client looks fine. Let me just pass this in, make sure that I have exactly the same code, but I believe it is. Oopsie. Pass this in here. We're still seeing this error. So let's make sure that we're getting the correct route here. So this could be just because we haven't done the underscore app. So we'll come back to this just in case we still have an error later. But let's just go over some of these changes that we just made. So we set up our client.tsx file and we added use client at the top, indicating that this component should only be used in client-side rendering. We're using to create tRPC React, which sets up our tRPC client, passing in our app router type. This is what provides end-to-end type safety across our API calls, so it's very important. Set up the tRPC provider is essential for wrapping our components and giving them access to both the React query client and the tRPC client. The HTTP batch link we use allows efficient batching of multiple API requests into fewer HTTP requests. Again, on the HTTP batch link, this significantly improves our performance by reducing the number of HTTP requests made by the client, especially useful when multiple calls are made simultaneously. So, given the scope of our app, not necessarily that important, but definitely a nice feature to have and really gives us some more weapons in our arsenal. So we're all set there, and now we're going to move on to that app file that we've been talking about and is causing us some errors right away. So let's go ahead and take care of that. So in our tRPC folder, this is a very simple file. It'll be easy to set up. We're going to create a folder called routers, and in this routers folder, we're going to create a root file for this folder called app.ts. And in here, we're going to import our create tRPC router from /init. We're going to set up an initial chat action here, which we'll create in just a moment. So again, we're going to have an error here, but this is it for our app router. So essentially we are exporting an app router. We're using this create tRPC router, and then we're going to pass in a series of server actions really here. So right now we have this chat action, which we haven't fully set up. But once we do, this is initially going to take our API route, which we have right, where's that one? Well, all of these really, but API/chat/route is going to be the one that we're looking at. When we get done with it, all of this will be turned into a server action instead of an API route. So then that's going to allow us to have that type safety where we really wouldn't even need tRPC, but tRPC is such a nice little wrapper that once you get past all this boilerplate, it really makes things nice and easy for us. So all of these API routes eventually, we're going to move them over to server actions if we can. If we have any issues, they can continue to be API routes, not a big deal. But for now, we're just setting up this initial one from /chat. It's not going to be fully baked, but we'll have some initial stuff there. Let's go ahead and comment and uncomment. And look at that. We're all set with all of our errors that we were fretting about in that last. And even over here, we now should be set. And we are. So all of those files are looking good. Obviously, we still have this error here because we haven't created this file yet. So let's just go through what we just created there. So we'll keep the router modular by defining different routes and importing them into this file. For instance, our chat route, which we'll discuss shortly, is brought into the app router using create tRPC router. This ensures our application remains modular and scalable. We'll also export the app router type to use it across the application, maintaining the type safety we've been emphasizing. So across all of our files, we're going to have this type safety. We're going to have exactly what types we're expecting on the server and client side. It's perfect. The app router is essentially the main gateway for our API logic, tying together all our individual routers and their respective procedures. So it's our gateway, it's our funnel point. So now we're going to move on to that chat action that we were just discussing. And beyond that, we just have one more file to go. But for the chat action, it's going to be very simple to start. We just want to we're not going to build out the whole thing like I said today, but we can do something here. We'll call this chat.ts, and we're going to import Z from Zod. And Zod is our input validation, which can be used both on the server side and the client side here, so it's great. That allows, this setup allows us to use that across both. We don't need the tRPC router. We do need the base procedure, so we're gonna go ahead and export const chat action equals base procedure dot input, and this is getting a Zod object. It's basically setting up the validation for what this input should be. It's an object with one field message that should be a string. We're gonna take that and do a mutation on it, so this is gonna be a post, and we're gonna return that message with the input.message. So very simple, nothing crazy going on. Obviously this will become what we just talked about a moment ago, this big guy here. So there's a lot of logic coming from LangChain and Vercel AI SDK right here, which we're gonna have to make sure is implemented correctly, make sure that it's type safe. I can see that there's something deprecated here. So this this starter template that we have is a little bit outdated. We might have to make some updates there, but that's all right. But overall, we have this initial chat app, and now we can go into underscore app. And even though we know this exists, sometimes just have to comment it, uncomment it, and we're good to go. All of our errors have gone away, and it's looking good. So like I said, we just have one more file to go. And this basically, we need to connect our tRPC setup with Next.js by setting up an API route. So we're going to go over to our API folder, which we already have for all of our different routes. And we're going to create a new folder in here. And this one's a little weird. It's going to be, tRPC. And then in here, we have tRPC in brackets. And within that, we have our route.ts. And we do want to make sure that we name this exactly as such, tRPC slash bracket tRPC bracket slash route.ts. For all API files have to be route.ts. So in this one, again, this is a little bit more boilerplate, but it's just about done with the boilerplate, so that's great. This is a simple one. We're going to import create tRPC context. There we go. But I don't want that. And we're going to import app router. We're going to import fetch request. There we go. And const handler equals fetch. I'm sorry. Got a little bit ahead of ourselves there. Const handler equals rec. Not that. Rec. And this is going to be request. And now we're doing our fetch request handler, and we're passing in our endpoint as /API/tRPC, our as app router, our create context as this here. There we go. And we're passing in our request as well. We're going to export as get and our handler as post. So we can do both get and post requests through this API route. So just think about anytime we run anytime we run an API request or a server action through tRPC is just running through this one API route. So there's one spot and it's serialized, so it would be impossible to guess what that route is. So you have a lot of safety there. So that's it for that one. And let's just go over that real quick, what we did here. So we utilize fetch request handler from tRPC/server, specifically designed for handling requests in Next.js 13 plus environments, making it easy to set up our endpoints for both get and post methods. We pass our app router and create tRPC context to the handler. This ensures that all our routes and procedures are available through this API endpoint. And this API route, as I said, acts as the entry point for all tRPC requests, providing a clean and organized way for client components to interact with server-side logic. So that's it. We've created all of the setup that we need for tRPC. We're ready to use it in our components and pages, server-side and client-side. We can hook up Supabase to it. We can hook up a headless CMS if we wanted to do that. A lot of different things we can do. So that is pretty much all you need to know for the initial setup of tRPC. Let's see. So the big benefit of using tRPC is the peace of mind that comes with type safety throughout your application. We never have to second guess the structure of the data we're sending and receiving, which reduces bugs and makes our development process so much smoother. So moving on to our next video, we're going to cover setting up the database and vector store. We're going to set up Drizzle or ORM, configure PG vector for vector storage, and add HNSW indexes for efficient similarity searches. Stay tuned as we continue to build out the foundation for our AI content creator. If you enjoyed this video, please like, subscribe, and turn on notifications so you can continue to get updates as we continue to move through the project. Thank you for watching.